eliminate the parameter. So what did we say? First step would be solve one in terms of for the parameter, right? Now you have your pick. There's like things that I don't like about either one of them. Like I don't particularly like the square root to deal with there, but I also don't like the fact that I have t in two different places here. And I think it'd be much easier to deal with the square root, just square it, that would get rid of the square root, than it would be to have to multiply by t plus 1, get all the t's on one side, factor out a t, right? So let's solve this one for the t. All right, I'll multiply by the square root of t plus 1. And then I'll divide by x. Okay, and then square both sides. T plus 1 equals 1 over x squared. Okay, one last step to solve for t. Subtract 1. Okay, so we solved one of the parametric equations for the parameter. Now what do I do with it? Yeah, in the other equation, in place of both the t's, put this expression. 1 over x squared minus 1 over 1 over x squared minus 1 plus 1. See how all I did was replace the t? I replaced this with this. Once, twice. Okay, now there's some simplifying I can do, right? You can cancel the 1's down here, right? So now we've got 1 over x squared minus 1 over 1 over x squared. But when you divide by a fraction, it is like, so multiply by the reciprocal, x squared. So this is 1 over x squared minus 1 times x squared. So distributive property, x squared over x squared is 1 minus x squared. So when we eliminated the parameter, here's our new rectangular, this is called rectangular equation because it's just x and y. 1 minus x squared. So what kind of a graph does this have? So quadratic, does it open up or down? It opens down, the y-intercept is 1. Right? It would look something like this. Now, is that the plane curve of these two? What's it missing? What does it not have that the rectangular will never tell you? It doesn't have the arrows that indicate the direction that this thing was traced as t increased.